Okay, here we go. 5.5. Listen. It says find y in terms of x given that d2y by dx squared minus y equals 2e to the x. And you're given a boundary condition that dy by dx equals 0 when y equals 0 at the value x is 0. So, first of all, you're going to find the complementary function to the homogeneous second order difference equation d2y by dx squared. Yep. Minus y is equal to 0. Okay, so we're going to set up the augs eq, auxiliary equation, and that gives you m squared minus 1 is equal to 0. Okay, so m is equal to plus or minus 1. Therefore, the complementary function so far is y equals a e to the positive 1x plus a e to the negative 1x. Okay, right, now the particular integral, so the pi...
Isn't it b e to the minus x?
Is it what?
Yeah,
Yeah, sorry, I'm just looking at this now. Scroll that across. Come back a bit. Back it in. Okay, yeah, that should be a b there. Right, so the particular integral is going to, f of x is equal to 2e to the x, and you can see that we've already got 2e to the x, we've already got solutions for that, so we're going to have to try y is equal to lambda x e to the x. Okay, so we differentiate this with respect to x, you end up with y dash is equal to, it's a product, lambda e to the x plus, leave the first, lambda x e to the x. Y dash dash gives you lambda e to the x. Differentiate the first, leave the second, so it gives you positive lambda e to the x again, plus, leave the first, differentiate the second, lambda x e to the x. And what it says is that we've got that is equal to that. So we have got one of those, so therefore I've got 2 lambda e to the x's plus lambda x e to the x minus y, and y happens to be that, which is lambda x e to the x, and that is equal to 2e to the x. So they disappear, and you can see that lambda must equal the value 1. So go back to the original thingamajig, which is just here, and you can say therefore the particular integral is y has the value lambda, which is 1, lots of x e to the x. Okay, and then you're going to add that to that. So therefore the general solution is y is equal to a e to the x plus b e to the minus x plus x e to the x. Okay, and that is the general solution. However, we're given a boundary condition, and the boundary condition says for this bit here that y and x values we know. So we know that when x is 0, y has the value 0. So put it into here, we end up with 0 is equal to e to the 0 is 1, so that's a, plus e to the 0 is 1 is b, and 0 times anything is gone, so we know that that is the first of our sim equations. Okay. Now, the next boundary condition, as you can see from here, requires dy by dx. There's no other way of getting dy by dx. We have to use the general solution, and we just differentiate it. So we get from here, and we differentiate that to give you y dash is equal to a e to the x plus b e to the x plus, and that's a product. Differentiate the first, leave the second, e to the x. Plus leave the first, differentiate the second, e to the x.
Minus b e to the minus.
Yes, minus, well spotted, minus. Okay. Right, and we know that x is 0 when dy by dx equals 0. So y dash is 0. So you've got the second equation comes from 0. What have we done wrong? Where have we done wrong now?
A e to the x minus b e to the
A e to the x.
Minus.
Is it minus?
You differentiated e to the minus.
Yes. miles away. Oh, I did that. Well, I do, because I'm stupid. Anyway, put it into there, and you end up with 0 gives you 1, so it gives you A. That gives you 1, so it gives you minus B. That gives you positive 1, and 0 is gone, because 0 times all of that. Okay? So therefore, I can say that, therefore, B minus A is equal to 1. That's equation 2. And all I'm going to do is add these two equations together to give you 2B has the value 1, and therefore B has the value 1/2. And if that's the case, then 1/2 minus 1/2 will give you a situation of 0. So therefore, A is minus 1/2. So we get the particular solution. Okay, I think they call it something else. Second order differential equation. Specific solution. They call it a specific, but I mean, it's, we call it particular solution. Well, I was always called it a particular solution. Right, so you end up with y is equal to, A has the value of that, so I'm going to put the B first of all. So I'm going to put 1/2 e to the minus x minus 1/2 e to the positive x plus x e to the x. And that is the general equation. If you went ahead and differentiated that, it would get back to the original just here, where I'm rubbing out just that. Okay, and that's the process for doing it. Right, over the page. It says, given that a particular integral is of the form lambda sine 2t, find the solution of the differential equation that for which x equals 0 when dx by dt equals 1 and when t equals 0. Now I always find this is always awkward to do because that's x is your y and t is your with respect to variable. Okay, so be careful how we go ahead and do this. So given that the particular integral is of the form of that, find the solution of the differential equation that. Okay, so I'm going to go ahead and find the complementary function, the homogeneous d2x by dt squared plus x is equal to 0. And we're going to try, and I usually write it down now, that your x dependent variable and independent variable, so your x is equal to, we're trying x is equal to a e to the mt. Okay, so let's remember it's of that format we're expecting the equations when we get our auxiliary equation. So org's equation, well, that's the same as always. M squared plus 1 is equal to 0, so it's imaginary. M is equal to plus or minus I. And what you're going to do with that, you know that was going to give you straight off y is equal, so I mean x is equal to, and remember it was a cos. You can do. Are you happy with going straight to the answer, or do I need to prove it? Do you want to prove it again? You sure? It is a cos, and it is 1 t plus b sine t. Okay, happy with that? If there was a number here, that would come out. Remember, e to whatever that number is, lots of t. Okay. So that's the, but everyone happy with that? Mm-hmm. That's what we get. So that so far that is the complementary function. Right, now we're going to find the particular integral, but we're told to try for the function of x equaling 3 sin 2t. It says try y is equal to lambda sine 2t. Okay. So I dare say that if you tried, well I do know, if you try mu, so plus mu cos 2t, that would disappear and have no effect. So they're saying, given that a particular integral is of the form of that format, yeah?
Is it y or is it a different variable?
Is it y? Yes, thank you. X, okay, is equal to that. Right, so actually, you lot, I'm actually going to do that. Look, I am going to slap in that just to show. So mu cos 2t plus lambda, what am I after? Sin 2t. So I got x dash, or x dot, is equal to, and that's going to give you minus 2 mu sin 2t, and end up with plus 2 lambda cos 2t. And that leaves you with x dot is equal to minus 4 mu cos 2t minus 4 lambda sine 2t. Okay, so you can see that all I've got is this bit here, which is this bit here. So I've got minus 4 mu cos 2t minus 4 lambda sine 2t, and I've got plus x, and x is the bit at the top here, so plus mu cos 2t plus lambda sine 2t, and you know that equals f of x, which is 3 sin 2t. Okay, so you know for a fact that there's no causes. That's why I said don't try it, but yeah, just to show you, you end up with basically the cos business. Do you agree? I end up with minus 3 mu is equal to 0. So mu is 0. So that's why they told you that there's only that as a particular integral. Yeah. So as I said, there was no need to show that, but I showed it anyway. So it doesn't exist. But the bit that does exist is minus 3 lambda is equal to 3. Therefore, lambda is equal to minus 1. So what we've got now is the particular integral is x equals, and what I've tried here is minus sine 2t. Okay, minus sine 2t. Right. All I've got to do is slap that onto the complementary function. So the overall solution so far is x equals a cos t plus b sine t minus sine 2t. Okay, so that's what we think the particular integral is as a general solution. But we're given some boundary conditions. Okay, so that's the general solution. Now the boundary condition says that x equals, not x, x equals 0 when t equals 0. X equals 0 when t equals 0. So you end up with 0 is equal to cos of 0 is 1, so that gives you a. That's 0, it's gone, and that's sine of 0 is gone. So a is 0. Okay? So that's the first shock, that first bit doesn't exist. Next thing is differentiate it, because we're told that dx by dt is 1. So differentiate that gives you x dot is equal to, differentiate that gives you minus a sine t plus b cos t minus 2 cos 2t. So putting in x dot is equal to 1, I think it said. Yep, when t equals 0. Then I end up with 1 is equal to sine of 0 is 0, cos of 0 is 1, so you got b, and cos of 0 is 1, so you got minus 2. So b has the value 3. So the particular integral is x equals, sorry, not particular integral, the particular solution is equal to, well, a is 0, that's gone. So I've got x is equal to b, which is 3, sin t minus sin of 2t. And that there is the particular solution, or the specific equation of that differential, second order differential equation right back up here. Okay, so that's why we're given those boundary conditions. Rightio, it was as simple as that.